well, I finished one question on gram-positive, gram-negative. So you should really know the principle. If you just memorize it, it's not going to help you. I'm also working on the problem for carrier-based transportation. I'm also working on a problem for glycolysis, citric acid cycle, and electron transport chain. Working on a problem how to interpret the figures from the steady concentration, also time, how to change that to slope. Well, unit conversion, scale, or micro, that question is always there. So every year I put question there. So, and in how to interpret the mortality rate, that's kind of from it's actually both from chapter 1 and the virus paper. In chapter 1, you remember we actually discussed mortality rate caused by different disease, right? So we discussed that. Right? So there is a question on the mortality rate. Now that I think that's for me, yes, covered everything. So let me see. But let me see. This for the online multiple choice, you just have to go over the assignment, make sure you know. Do you have trouble to see the previous homework and assignment?
We can see it.
You can see all of them? Okay, so I can even let me. Yeah. So if you can see, I remember chapter 1 and 2. You can actually see the answer directly, so that shouldn't be a problem anymore. Chapter 3 and
change it to chapter 3 and 4 so we can see the correct answer.
Yeah, let me see. Chapter 3 and 4. Let me see where this is. Chapter 3 and 4. For the makeup, you can also see the correct answer, I think. Oh, only 6 people are doing makeup. Okay. Let me see. No, that's the question. Let me see the setting. This is the question behavior. So review option. Yeah, actually you know whether it's correct and the correct answer. Whether correct right answer. Let me make sure all the right answers are there. So yeah, so this is chapter 3. Let me do this also for chapter 4. Make sure all the correct answers. Chapter 4. Okay, makeup version. And some of the question may be slightly different from what you have seen. For example, if it's say which answer is, I don't know. But I may say if the answer which one is the largest, I may change the question. What is the smallest? If which statement is true, I may say which statement is wrong now. So but the same content, I just modify a little bit. So review question, right answer, right answer. Okay, so for chapter 4, you should also be able to see all the right answer. Okay, now let's work on the open book one. Do you need to work on the Excel? How to? Okay, let's work on the Excel. Excel will be part of the open book. Yeah. So if you don't have a computer, you can use one of those computers. Yeah. So let's do. Let me also Excel. So, cell down. So, let's put some random number. What do we want to put? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, that's not 10. Then we put some random number here. 0.5, 1.1, 1.5, 2.1, 2.7, 3.2, 3.2, 4.1, 5.3. Okay, so we have two column of number. We want to do a scatter plot and do a analyze, add a trend line of these two rows. So, well, okay. Before I start, I told you I don't use Excel very often. So if I embarrass myself, you know, that's because I'm not familiar with it. What? I'm sorry, what?
It's 8 and then 10.
Oh, I skipped 9. Okay, I did that on purpose. Okay. No, but the problem is to analyze the two scatter plot. So let's go to chart, scatter plot, mark the scatter. All right. So I guess by default, the first one is horizontal axis, and the second one is the vertical. You can see from the scale. So now you can actually also, if I remember, if I double click this, you can. If I double click this, you can make the axis in, say, log scale. Yeah, this you can do that in log scale. I just double click on that. But I'm not sure whether this works on all versions. Sometimes in your computer you might use a different version, especially if you bring your own laptop, right? So unfortunately for Microsoft, every version they come out, the features are slightly different. So that's unfortunate. Yeah. And so yes. What? Oh, how do we? Yeah, exactly. When you log on, you need to. When you log on, you probably need to do this. You say file, laptop. There's a number there, and then you do backslash file laptop, and then put the. And the password is spell 1881. Maybe we'll do this. So this is one. Okay. So now you probably can double click on this also make some change of the figure legends. Let me see. Oh no, it's not. How do I? I'm going to let you figure out how to change the word. Instead of just say serial 1, you may want to change this one. Okay, so how do I add trend line? I'm going to right click on this. It's good. This one pop up, say add trend line. So, and then say I'm going to add a linear model. But you also want to know the coefficient of determination. which is the R square value. Let me try options. Yeah, it does say this. Display equation on chart and display R squared value on chart. Then I click OK. Then it shows this. Right. So if the question asks you, well, not if, there will be a question ask you to do a scatter plot and add a trend line on the Excel data I provided to you, and you should do this and then just upload the Excel file with the figure there. So, and then the next question might ask you the, well, in the open book exam. Yeah. Yeah. So this one, R squared is, wow, amazingly close to 1. If R squared close to 1, that means the linear model. Yeah, this is a very almost amazing correlation. So, well, I made it up. So, but if R squared is 0, what does that? But how does the line will look like? Excellent. Yeah. So basically, the line will be almost horizontal.
Are you gonna access that to like, is it positively correlated? Like a simple 1-point question?
I'm going to reserve that question, but I haven't made up the question yet. But I tell you, there will be a question on this, right? But the choice will be yes.
Can you go to the workbook that we have to do for the quiz so that we can practice?
Yeah, especially the last.
Because it was so easy.
Okay. Yes, that's right. Yeah. Okay, that's a good point. So this is one example. Let me close this one. I don't even have to save this. Let's download the Excel file equalize genome investigation. Save this one. Where did it go? No. Where did the write down? Okay, so here's the. I think I need to make the screen smaller. Zoom 50. Oh, that's probably too small. Zoom 75. Okay, but so there are. Let's see. One question is asked about the genome size and what? Gene number? Okay, so you need to find a way to highlight these two columns. If you have trouble to do this, you can just copy paste them to a new place, right? So if you have trouble to highlight all this, or you want to switch the X, Y, so it looks more pretty. So I can just copy this and put it at the end of the file. Right, so I'm going to put it here, paste it, and then I'm going to copy the gene number, also paste it here. That way, it's much easier. I can even flip this one, cut and paste, and then I can just do this, and then I'm going to say chart. Where is the scatter plot? Okay, I'm not sure why all of a sudden it changed. Oh, okay, for some reason the scatter plot is here. This is a string. Oh, here. Now it's a scatter plot. I don't know why all of a sudden the menu changed. At least you should do a scatter plot. Well, it looks like the range of the X, Y axis is not very good. It actually starts from 0 to 7,000, and I know the sample do not start from 0. So I want to change the range, make it look at least more informative. Instead of 0, I'm going to change that to 3,000. Just to be safe, 2,500. I forgot what's the minimal value. Okay. Okay, so now this one, the horizontal axis looks a little bit better. The vertical one, the minimal minimal is how much? 3. I'm going to change to 2.5. 0.5 million base pair. Okay, so I guess I can do better than this. If I change to 3,000, seems to be still working. Change to 3.5, still working. But that seems to be the smallest number right there, right? So the smallest number, actually, if I click on it, whoops, it actually shows me it's 3,749 genes and 3.976 megabytes. If I click on it, it actually shows it. And what's the largest one? The largest one is a little tricky. So the largest one is a little tricky. You may have to zoom in if you really want to use the method. But there is actually a better way to do this. So if I go back to the bottom of this, so where is the genome size? This must be a genome size. How do we find out the minimal, maximal, and average? In Excel, actually providing many functions. In fact, people in Wall Street or industry, they use Excel to do some very sophisticated work. So in Excel, if you type equal sign, that's actually pop up, give you a functional version. So I'm going to just point to this cell and then type equal sign, and then that's actually going to input a function. The minimal value is just minimal, and then if I type the parentheses, it actually pop up. How should I pick the? So it turns out in Microsoft they just define this. So this is which column? This is column G. So I know the first one is a title. So this starts at the second cell. And how do I specify the range? If I say G2 from to the last one, the last one is on this row. That's 81. So I just type G81. 81. That should tell me, yeah, that is the smallest number of the genome size, right? So then you can do this for maximal. The maximal will be MAX maximal. Also, and that's 5.85. You can also do this for average. Average, see, now it actually gave you a hint. It looked like I want to use average. So average, this would be G2 to G81. Average 5.098, right? And in the exam, I'll probably say 5.1 something. It round up the number. All right, so you can do this for what? Why do I start? Someone explain this.
Oh, I didn't see.
Yeah. The G is the column number, 2 is number 2 cell. The first G1, that's the title of the. It's not the data. Yeah. So okay. So now the nice thing about doing this, if you want to, we know that's minimum, that's maximum, that's average. If you just copy paste, put this to the gene number, you actually just got repeat the same thing. Yeah. So that's the minimal gene number 3749. That's the maximal gene number. That's the average gene number. So just all the function has defined, then you just copy paste the code to there. Okay. So but let's go back to the plot. Okay, how do we add the trend line again? Yeah, I'm going to right-click on those dots. And then, in my case, I say add trend line. What type of trend line I want to add? The linear one. But how do I know the R squared, the coefficient determinant? Option, go to options, and then select the display R square value on chart, and let's also display the equation on chart. Okay, and then okay, so you may want to pull this one to white space, so at least I can see it more clearly, or you can see it more clearly yourself. Okay, so in fact, in bacterial genome, the genome size and the number of genes has an extremely good correlation. So this actually doesn't work in eukaryotic system, but in prokaryotic genome, this correlation works extremely well. But it also tells you, I remember the textbook, so E. coli genome, this is how big it is, how many genes. In reality, we know it's actually really fluctuating. Yes?
In regards to the last question on the quiz, it was like find the non-protein.
Oh,
Basically,
that's right. There's a question last. Right, yeah.
Basically, you have to subtract two things and then do this.
Right, yeah. So okay, so what?
Subtract one column from the next.
Yeah.
Right, yeah. So how do we do subtract? So I'm going to say this will be non-protein genes, and this will be I put the equal sign at function. I select the gene number, and then minus the protein number. Right. So that's for this genome 358, and then since this is a function, I can just copy paste the entire row. Let me see, not the entire row, entire column, and goes down all the way to 81. Right. So paste this there. That's the IV number has been calculated.
Wait, so what did you do? You said gene.
I
You just put.
Right, I just copy paste the first one. I did the first one and then copy paste the first one to the entire column.
You just put O2 minus the other column. I missed the.
Okay, sorry. Let's do this again. How about you want to come here and do this? First, what should I type?
You just put O2 minus.
Excellent. Equal sign, and then which one should I select? Yeah. So go to column O. You can actually just type it. If you know it, you don't have. You just type it O2, and then minus. Which one should I minus? T2. Yeah. That's yeah, and then just copy paste the entire column. And then did I also ask what's the minimum maximum again? Oh, and then you can just, we already did the minimum and maximum. You can just copy paste that part, put it here. So the minimum number of non-protein coded genes is 102. The maximum is 1,000 something. That's actually I kind of wonder why that happened. That seems to be an outlier. In fact, if you do a plot, the question asks you to do a plot of this one. Did I ask you to do a plot of this with the genome size? Yeah. So okay, let's do that. Instead this time instead of moving them around, let me just highlight all of them. So I'm going to pick the first one and then highlight the 81. Oh, it didn't highlight. Okay, let me copy paste. Sorry. So I'm going to put here. Okay, so but by doing that, I want to remove the last one. Okay, so the question asks you to do a plot between genome size and non-protein coding gene. Okay, so I'm going to select these two columns. And again, do a plot, scatter plot. Insert chart, looking for the scatter plot. Excellent. Here, mark the scatter plot. Okay, and then I will just right-click on it, add trend line. Option, display equation, display R square. This really doesn't look nice. Yeah. So there, it's 0.00438. Is that what you get?
So let's say no correlation.
Is there? Yeah. What? Let me also change the range. So change it to 3. Okay. Yeah. There's you can add a trend line, but it's so poor that I don't know how to get the p-value using Excel. Has someone figured out a way to find out the p-value using this?
T-test?
No.
T-test?
P-value is for significance. So you see, you can add a line to almost every data, but is that line significant or not?
You have to.
What?
So I was doing this today.
Oh, okay. You are, what course teach you SAS?
Dr. Brackey. She's in the psychology department.
Okay. So in psychology they teach you use SAS and SPSS. Oh.
What are you trying to compare?
Here we try to see whether there's a correlation between the genome size and the number of non-protein coding genes.
Well, wouldn't it be 0.005?
No, the R square is 0.00438, but I didn't ask you for p-value since I cannot find it myself in Excel, so I didn't even ask this question. Yeah. But I guess in some later on in this part of class, I will teach you at least use R to do some analysis. That's give you much more information on this. So we can even analyze the same data again. So.
He's trying to compare it to the but I think we have to
Non-protein genes and the genome size. No, I'm not asking to do a t-test. Linear regression has a p-value assigned to it. Yeah. So but the Excel doesn't give us the option to show that p-value. Yeah.
Well, it does. When I was Googling how to do this, I thought linear test. It's like F lines T or something like that.
Oh, okay. There is a function called lines T something.
Yeah.
Okay, why don't you?
I don't know how to do it.
Yeah. Okay, I'm going to give that the extra point if someone figure out the p-value. Yeah. So, but we haven't do that in the assignment, so I'm not going to put that in the exam, I guess. Yeah. Okay, so let's do another exercise. Let me show which exercise. Oh, there's a formula in Excel how to do p-value. Well, why don't they come up here and do a demo? Yeah. How do you get the p-value?
I don't know how to get it on the.
Oh, yeah.
I don't know how to get it on the graph, but you could get it underneath the tables.
Okay, that's fine. Yeah, that's the. How do you get it in this table? More functions.
Wait.
There, right here.
Oh, wait, it came up there?
Yeah, because there are two screens.
Oh.
Wait, you can drag it over there. So.
Oh, okay. Oh.
Yeah,
How do you?
You can scroll it down.
Hold on. On mine, I'm assuming it's this, but
No, that's relevant.
Yeah, there should be a STDEV one. But I guess you could just type it
Oh,
in
standard
manually.
deviation.
Yeah.
Oh, I see. You are going to use standard deviation plus.
Right.
Oh, I see.
Not the same thing?
Yeah. You can try, but I would be impressed if you can use that to calculate the p-value.
Okay, in that case, for this one.
Yeah.
Right. From.
That value will be used to calculate the p, but it's actually going to take some effort.
Right. So this would be from what? To
381.
381. And that should be it.
No, that's a standard deviation.
Right. Well, that's yeah.
That's
I
not
thought that's on the
p-value.
P. Okay.
Oh no, standard deviation is not p-value. Yeah.
But that's how you
But
do standard deviation.
Yeah. No, standard deviation is standard deviation. But standard deviation can be used to calculate the p-value.
Okay.
When you compare the standard deviation of the two, the p-valuation is compared with the product and normalized. There is a formula for that.
Okay.
Yeah, as part of it. So I thought you were going to do it, but anyway, good effort. Yes.
So PW, that shows the significance.
Right. Yeah.
So we're trying to find
Whether we have a very poor R square, but is this still significant or not? Actually, we don't know yet because I didn't calculate p-value. Okay. So let's work on another question. Hold on. This is a very important question. You need to know this. With the electron transport chain question. Yeah, this question you should. Let's work on this question. One molecule of glucose has gone through glycolysis. How many protons will be transported by electron transport chain? And this is the open book. In fact, you can use everything you can get right now.
what do you mean by study procedure?
How you reach the conclusion?
Are you restricted to know that how many goes per
Yeah, that's wrong. Well, if you Google, I doubt you won't Google find it unless you won't know it. And there's no way in the textbook I could say that. The textbook didn't have this answer, so how do we know that? Yeah. The textbook tells you all the principle, but you need to apply that principle to find the answer of this. This is actually a very important exercise. I'm actually quite surprised. Textbook actually don't have an answer for this, so I basically ask you to work out this answer on your own. So. So I can show you some important slides which is related to this question. Let me find out the slide you can use. Oh, yeah, this is let me see, slideshow. What? No, this, yeah, this. Well, in the long one also has this one. The short one is just like I pick some important one I often use. So this is actually the one of the key slides. You need some extra information to get this one. So let me see. You also need this slide. Oh, these two slides had both information. Sorry. So this slide has both the electron transport chain and the summary of the glycolysis and CAC cycle. So this slide had all the information you need to answer the question. So
what's the show procedure?
Well, what does the question ask you? How do you work out the solution? Right, yeah. Right. In any, I don't know how you are going to approach this question, but
Is that 10?
what?
Electron, is that 10?
Well, here's the electron transport chain. You can see how many protons are pumped out, right? So NAD give 4 protons here, and then in the first, this is complex 1, 4 protons are out. Complex 2, another 4 protons. 2 and 3 give out 4 protons. Complex 4 give 2 protons. So altogether, from top to bottom, there are 10 protons are out. Yeah. Right. 10 protons are out, but but for one glucose molecule it goes into glycolysis and finally come out from the CSC cycle.
So are you just doing the protons strictly from the electron transport, or do you want to also add the 2 from glycolysis as well?
Well, the question. Look at the question.
Yeah.
Yeah. So the question put the glycolysis there, right? So, and this apparently is for a bacterial cell. Bacterial cell, this both glycolysis and CSC happen in the same in cytosol, right? So. What? 12 what? No, that's not even close. Yeah. Yes.
Why isn't it more hydrogen for glycolysis? Like, doesn't NADH transport 2 hydrogen? NAD?
Yeah, NAD, NADH. It's.
So wouldn't it be like 2 times 2?
What do you mean? I'm sorry.
The 2 hydrogens, which come from 1, and then it's 2 NADH, so it's 2 and plus 2 is 4.
For what?
I think he just was talking about the second proton. What she's talking about is, you know how on NADH there's an H attached to NAD, right? In addition to the long proton. She's asking, do you add the H? Do you include the H that's included inside of the NADH?
If you, well, look at the question though. how does the NAD goes to NADH? It actually happens there.
NAD transforms to NADH, right?
Right.
So you're saying only one hydrogen goes to it?
It actually tells you here, go to complex 1. Here. For the NADH here, it actually tells you to complex 1. Actually, the slide actually tells you how this is going to occur.
So you're saying it's already included in the chemical?
I'm basically saying the question asked is actually not related to the problem I'm asking. That's part of the reaction. At the end of the reaction, this go to complex 1.
For complex 1 is 4.
And complex 1 pump out the 4 proton, but that's not the end of it. This will go all the way down to here. So for every NADH, it's going to have how many? For each NADH, it's going to have 10 protons out of this. Right. So, but there are 2. So how many protons will come out of this? Maybe 20 just from this. And then how many of this?
40.
Right. So from CAC, you have another 4. Have a FADH. Right. So just this reaction alone going to give you 20 protons. Right. Right.
So what's related to the question?
Here, NADH 4, you have 10.
And then you add another NADH, you get another 10.
Right, yeah.
But you get 2 NADH. That's just from
Right. And just for glycolysis, you already have 20 protons come out.
20, yeah, 10 each. 20 protons total in electrons.
It doesn't include citric acid.
Yeah.
And then you can try to calculate how many protons the CAC is going to give you. You have 4, so that should be 4 times 10. That should be let's say 40, but there will be. This is just one for one pyruvate. One group should actually give you 2 pyruvate. So this should be times 2. No, that's still not right. You also have the FADH and FAD. What? Yeah, it should be. Yeah, that's actually that is the question. How many going to get? How many proton will FADH give you? Where is the FADH? It's 2 complex 2. Complex 2 give you how many protons? 4, and then so FADH give you 6 protons each. This give you 6 protons each. Yeah. Why that's the case? One FADH should give you 6 protons. Right. So this is 2 complex 2. Complex 2 is here. It has 4 protons, and then goes down to the last one. There will be additional 2. So that's 6 protons for FADH. Yeah.
We're still going to one FADH2.
No, that's not correct. Why you get 2? Because that's right, yeah. Because one glucose gives 2 pyruvate.
Yeah. Okay. Do the separate each pyruvate there.
There's 4 NAD and 1 FADH or 1 pyruvate. What? Excellent. 46 for 1. So you have so essentially you have
How do we have 6?
okay. How many?
And then the 2 are the
How many protons should FADH give?
That's 20. But I was adding all the NADH.
I said
So that
20 plus 12, so NADH plus the FADH is 2. Add those two together, we should have 32.
32. Because you have
Then
4
more.
NADH.
Okay, so we're on the right track though.
Yeah.
Okay.
It should be
I thought you were
46.
organizing the NADH together, but I
So look at this one. FADH goes to complex 2. Complex 2 is here. Remember I tried to draw a river with the complex on top of it as the hydraulic
Oh, you
power
got that
station?
wheel.
Yes.
Oh, we saw the.
That's why I'm trying to say here.
Okay.
So everything here going to at high energy they're going to flow all the way down.
Okay.
Yeah.
That's why you wanted to draw it.
Right, yeah. So you put something here, it's going to flow from 1, 2, 3, 4. So the top one going to flow from the NADH is at the highest level of energy. It's going to flow all the way down here, and that gives you 4. If you count the money, that's 4 checks, I guess. so NADH is a very heavy ball. If you put that more, it gives you more power.
I think it's easy to know how many
For FADH, it actually goes not to the highest level, it goes to the second level. This one gave 4 and then 2, so that's actually 6. It has lower energy, but it still gives you 6. Check. 6 payout. Yeah. So there you so for 1 glucose. Glucose, we have 2 NADH from glycolysis. And then from CAC, we have 2 of that, but each one gave 4 NADH and 1 FADH. Right, so we should time that one. And the question should say you should sum up everything here. Right. So in the end, we have 10 NADH plus 2 FADH. And this is 10 protons, so 10 times 10.
10 times 20. 10 times 10.
Right. 1 NADH gave you 10 proton, right? And 2 FADH gave you 6. So 112. So.
For this one, we just summed up like glycolysis and CNC.
Okay.
Right, yeah. So but 1 glucose gave you 2 CIC cycle, 2 pyruvate. Right. So.
And 1 FAD?
That said, this is something work on paper. In reality, probably is not precise. I guess that's why people don't put it in the textbook. And also in eukaryotic system, glycolysis and CIC are decoupled. The glycolysis, right? So I guess my assumption here, this is a say E. coli is doing it this way. Yeah, so yes.
I get 10 NADH.
Plus 2.
You said what?
The 2 from the top. Yeah.
NADH, you always start at complex 1 because it's the highest energy level, so then you add the 4, 4, and 2. So it's something at the all the
Okay, so your friend help you better than I do. Next time I'll. Why do I? So why do we have 10 NADH?
How many does CIC?
That gives you 6. Or no, it gives you 8. 8 NADH. Because it's 2 pyruvate, so each pyruvate gives you 4 NADH. And then from glycolysis, you had 2 already. So that gives you 10. So then just the question back to the
And we go to see add twice. This is probably all.
that's just,
Okay, I don't know.
I mean, CAC is 2 pyruvate, so it's like, I guess you could say that's
There's appreciate that. Considering you did your good. So then,
Okay, so next time I will ask you explain to your friends. All right, so that's one question. And you also want to work on the scale or Michael? What? I'm not sure which question. Oh yeah, it is question number 2. Okay, yeah. So the length of chicken egg is 60 millimeter. The length of E. coli size is 2 micrometer. The size of a virus is 100 nanometer. So if E. coli is as big as a chicken egg, how big will this virus be? Uh-huh. Oh, can you see the open? Actually, let me double check. Make sure you have. Okay, yeah, I never looked at something. Okay. But I found a way to do it.
That's how I would do it.
Okay, I want to have a volunteer come to the board to work on this. Come on. Who is going to volunteer? I have my feedback here if you want. No, I finished the discussion. Sure, yeah.
So look, that was
that's always like student questions.
Did you do this? I had worked out,
That's how I didn't have the other right and then I just started playing with numbers. Then I started getting more.
yeah.
So all the length, the length of the color. The size of the virus.
Okay. Why don't you take a piece of paper and work on this on the paper and that's basically the row I'm going to take. And then I come my mother here.
So wait, I gotta find what?
The point is you need to work on it.
Millimeters or micrometers? Like the first one? Oh, it's gonna be good, yeah. Yeah.
Oh, that's right. For both closed book and the open book, you can use a calculator. I got to mention. I see someone using. I realize you are allowed to use a calculator. Although for the open book you have the Excel, so you don't really need it. Yeah.
You want every single person to submit one, right? Every person to submit that.
Yeah, right. That's basically my low time. You want to okay.
Where did you come from?
That's correct.
Is that 3 millimeters? Okay, what did I do wrong?
Okay. I didn't check. I just did that.
Yeah. We want to explain that to the.
Oh,
Okay, here's the demo.
Okay, so because it's asking for your scale in the size of if the virus was the size of a chicken egg, I converted all of them to millimeters, and then divided it to find x, and I got 3.
I have some questions I want to ask you. Yeah. Oh, okay. Make it pretty clear. Okay, you got done. Okay, I guess I should leave some time for you to ask free questions. What kind of question you want to work on?
Oh, yes, I have another question down here.
Uh-huh.
Is E. coli, or no, I'd rather say, is E. coli gram positive or gram negative?
Why is E. coli so sad? So, okay. Yes. 7 and 8. This. Oh, okay. So, this is a. I guess I should change this to enzyme reaction rate to product. Enzyme reaction. That's right. To substrate concentration. Yeah. So there's a mistake. This should be concentration. This should be substrate concentration, but I forgot to change it. So that should be substrate concentration. Yeah. So sorry. The horizontal X should be labeled the substrate concentration. Yeah.
Is the vertical still rate? The vertical is still rate.
No. Actually, to be more precise, it should be product concentration. Yeah. So that's this seems to be changed to product. So enzyme reaction rate versus product. Product concentration. Because this is a negative feedback loop. For the negative feedback to occur, this had to be product. Because the definition is the substrate always on the left-hand side. So the substrate changed by an enzyme to product. So I'm looking at the enzyme reaction rate versus the product. This. The question asks you which one actually represents the negative feedback. Yeah. Well, it's negative means you had to break it, right? You apply a break, that's a negative feedback. So it has to be something goes up and then goes down. Right. So which one goes up and then goes down?
Oh, you have to go up.
Right, yeah. What?
Oh, that'd be Z.
Right, then slow down. Yeah.
Or you think, can it start up or have to go up?
Well, in theory, if you slow down, it means it's there's a brake applied to it. Yeah, just go up slowly. Yeah. If that's the case, basically, I mean, this can be, this also cannot be, this. So actually, only this one makes sense.
And the slow down and stay constant.
As long as it's if it's very fast and then start to slow down, it indicates that some brake system make it happen.
That's what I'm saying. So it has to make it down and down.
But D is actually not a negative feedback. B well, we're talking about enzyme reaction here. D is basically why is D is completely wrong? So lava goes down. I guess now that I think about it, D is, I guess it's.
That's a wide rate. Oh, there's something. So with the rate goes down.
Yeah, actually D is also possible. That's a good point. Yeah. D is also possible.
So what's the difference?
So D is also possible.
Yeah. D is also possible.
So what's the difference between B and D?
B basically just slows down, and D is actually brake so hard it actually stops. It actually goes up to. Yeah, so that's a good point, I guess.
Are you saying that it slows down to suddenly?
Yeah, it actually almost goes up to braking so hard.
Okay.
Yeah, it goes to completely stop in the end. Right. Yeah. So, that happen very often actually. Yeah, but I guess in theory that is possible. Yeah. So, okay. How about number 8? What? I guess both this and this make sense. Yeah, a possible answer. Yeah. Yes.
Question about this because I'm getting 2 times 10 to the negative 4 not 3 millimeters, so I don't know.
2 micrometers.
So 6 times 10 to the negative 3 times 1 times 10 to the negative 7 is 6 times 10 to the negative 10 because you add this.
Oh, you put this one here?
Cross.
Yeah.
This is mine. Because it's
Oh, I see. Okay.
Okay, so in a bacteria, this actually goes back to the electron transport chain and proton gradient. So bacterial cell, its cytoplasmic plasmic membrane is leaky for proton gradient. Which of the following is not true? Comparison to the wild type bacteria. Well, if the proton is leaky, it's going to generate fewer ATP because protons are going to generate ATP, right? So B is true. That's not the answer. Answer is not true. Electron transport chain has no effect. It should still do the same thing, right? So C is also correct. Glycolysis and CSE will generate a 10 NADH2. That should be also the same because the mutant doesn't affect those. So BCD are also correct. A is the only one actually wrong. So besides D and A cannot be both correct, right? So if you pick B and A has to be wrong. So in fact, if you answer the question number A, that proton you should also be able to answer. It cannot, right? So there I tell you, you know that's 10 NADH, and you should also be able to calculate the proton. Right? So, yeah. Wow. right. Yeah. So, okay. We already passed the class on time, so it's good you are still you're still. But if you want to leave it, yeah. I think I'm done with it. Okay, thank you. Yeah.